we're moving to our next speaker. Neil Ternowetsky is a CTO and product manager at TRAINFO Corporation. And he's going to be talking about responsible machine learning solutions for North American supply chains. Welcome, Neil. The floor is yours.
Yeah, thanks for having me. Great to be out here. It's going to take a second here and share my screen. All right, let me know when you can see it. We all set? Oh, can't hear you.
Yes, we can see you. And see the slides.
Okay, perfect. All right, well, yeah, thank you very much for having me out here today. I'm Neil Ternowetsky. I'm the Chief Technology Officer at TRAINFO, and I want to talk to you about how we look at responsible AI from a corporate perspective at TRAINFO. My presentation won't necessarily be looking at a case study of responsible AI, but more looking at who is TRAINFO, how do we implement AI, and what are the responsible elements that we take into consideration with AI. So who is TRAINFO? Why do we exist? Well, the railroads move 1.7 billion tons of freight per year. This is actually 1/3 of all the US freights that is moved. And anyone who's peripheral to that network, it's kind of a black hole of what's happening inside that network. You don't really understand what's happening until it comes out the other end. And this creates major issues in road safety. Every 3 hours, there's an accident at a rail crossing, and the fatalities and the injuries that happen there are really significant. But one of the things that really grabbed me was the economic impact of each of these incidents. It costs our economy, $10 million per incident during these events, which is about $30 million a day is the cost of an accident at a crossing. Traffic congestion, we see 1.7 million blockages per day. That equates to about 300 million vehicles impacted every single day across North America, and close to 1 billion hours of delay that occurs there. Emergency services, we see about 1 in 30 emergency responders being delayed at active rail crossings. And when you look at the cases of cardiac arrest, every single minute of delay in response time results in an increase of 50% in fatalities. So it's a pretty big issue on that side as well. And then looking over also with supply chains. We're seeing it right now, especially with the volatility in our supply chains today. But as soon as you get a ripple in that chain, there's a cascading impact that just disrupts a lot of things. And so when you have a bit of a disruption in the rail network, we start seeing the failing just-in-time systems. And so our solution. So we are democratizing train data. So we have our own sensors that we install off of the rail right away. So we don't have to work with the railroads to do any of this stuff. And in fact, the railroads love that. They get complaints about all kinds of issues at rail crossings, and more often than not now they give the city our card and they contact us and we start addressing the solution. And we spent a long time investigating technology to detect trains, characterize their movements. And it wasn't as simple as I thought it would be going into it, especially when you try to consider building a solution that's going to be scalable. You don't have to spend hours and hours of design at every single site to, calibrate algorithms and all those kinds of things. And so we tested, camera, LiDAR, radar, microwave, infrared, accelerometers, and we ultimately landed on acoustics. And so, we use the acoustics to detect the presence of the train. We get really rich data in terms of characterizing the movements. And it was really interesting because when you look at things like camera and radar, we got great data for detection, got great data to say what's the speed of that train at the very front of the train. But after that, we're working with Continental, the automotive radar manufacturer, and they were even saying we're not going to be able to get you better data after the train's there, and you have a 1.5 mile long train. That speed can change pretty dramatically throughout. And then with cameras, the monotonic characteristics of each rail car made it difficult to identify unique characteristics to say that this car is this car and it's moved this much in terms of position of the screen. And so we found that to be another challenge. And also with both those technologies, we would have to be very specific as to how do we line up sensors when we deploy them, and adding extra costs to rolling this out. With the acoustics, we are basically able to slap it on a pole within 30 meters of the crossing. It takes about an hour to install it, and sensor is self-calibrating, and within 2 days we're live. So that's the one side of it. The other piece here is we ingest a lot of data, GPS data, vehicle telematics, rail crossing inventory, shipper and port records, satellite imagery, and basically looking at the relationship between these third-party data sets and our data sets to be able to understand cause and effect and to look at the relationships between these elements. And it all gets fused into our cloud environments. And today, the products we're taking to markets are really about predicting train movements. We're doing things with traffic management where we are, reducing congestion and delay. We are ingesting data into emergency responder dispatch systems to automate the unit selection and recommendation for dispatching. And we've done a lot of work with connected and autonomous cars. Just trying to hide this here. In the automotive industry. So we've actually been working with BlackBerry QNX, and it's a lot of people get surprised when I say BlackBerry, but they're still a pretty major player in the automotive industry. Vehicles 2008 and newer, they are using their operating system in those vehicles to build autonomous features, adaptive cruise control, things like that are built on that operating system. And so we've been working with them for the last couple of years, looking at connected vehicle applications, looking at autonomous vehicle applications. And the reality is, the market's not quite there yet. With the connected pieces like with CarPlay and Android Auto, that developer ecosystem is still quite locked down. With autonomous, we're probably looking at the big challenge there is the automotive sector is very worried about opening up the network. What else can talk to the car? What can influence the car's movements? Right now, the best security is designed is to have the car be isolated, so that there's no risk of foreign ingestion of data that's going to negatively influence the vehicle. So we're still looking at those pieces there. So like I said, the market's not quite ready for those kinds of applications just yet. But we are also doing research into predicting freight demand, doing some work with the Port of Vancouver, Port of Charleston, looking at how the port operations are changing based off of disruptions and changes into rail activity. And then, the more data we get in to pair up with the data that we have, the other insights we're trying to glean from it to be able to, find new products and explore. And so, we've been very happy with our rollout go-to-markets. We started in 2018 going to markets, and COVID was really quite tough for us. We weren't able to, there's a lot of municipal budget freezes where cities weren't able to, acquire our technology. So we were basically flat for a couple of years, but so minus those 2 years of COVID, we've been able to get ourselves into 20 cities at over 100 crossings, getting great feedback from the markets, and it's going quite well. And so, how is TRAINFO enabled by AI? So we use a lot of different techniques. We use Bayesian networks, Bayesian regression, ridge regression, various clustering models. And, we haven't needed deep learning. And at this point, not that we haven't tested with, neural networks and things like that, but the value we see getting from those items today, it hasn't been worth it. And what I mean by that is, the neural network, it's very tough to understand the relationships that are made inside of there, to be able to glean new insights, to go why, to be able to, what are the data sets should we be bringing into this? And so we take that very seriously because we are very young in our company's lifespan, and we want to understand what else should we be bringing in? Why is the relationship being made the way that it is? And so it's much easier for us to unpack any of these other types of approaches than trying to reverse engineer than what the network did to be able to grab those insights. And not only that, but we're talking about responsible AI. AI is often seen as a black box. And so for us to be able to unpack it and explain it and get third-party validation on the approaches and why it's coming out the way that it is, there is a bit of a risk that we are putting a bit of the proprietary nature of our technology out there. But with government markets and the people that we're working with, it's been important for them to be able to understand, have confidence that, okay, we trust your predictions. Yeah, you're showing me this, but what happens in these scenarios there, especially when you're dealing with emergency responders and things like that, having that visibility has been really critical. And I won't say that we won't ever go to looking at alternative approaches with neural networks and things like that. But for today, for where we're at, it's been really important for us to use the right tool for the job. And it just hasn't been those things at this point. But like I said, we have tested various approaches. And what do we understand? So using those different approaches, we understand future train movements. In a lot of cases, we can understand a train movement's going to happen as many as 20 minutes before it's going to happen. We know how long it'll be there for, how long till it gets to that location. The characteristic segmentation of the rail network is a really big one for us. And so what I mean by the characteristic segmentation is that if you look at the rail network as a graph, if you will, with edges and nodes, not every single edge or segment of the network is going to be created equal. Some are going to influence freight movements different than other ones, and we've been able to classify the entire network to understand which parts of the network influence what more, adjacency to a port or to a terminal or to a particular shipper or manufacturer. We've been able to characterize a lot of that throughout the entire North American rail system and train the model to understand how are these segments weighting freight activity. We're able to infer, the commodity being moved. Even from our acoustics, it's telling us a lot. It's telling us, is this car loaded? Is it not loaded? Is it a flatbed? Is it a intermodal container? Pairing that up also with our segmentation of the rail network, we can draw those things together to understand, okay, this is what's being moved here. Short-term changes in regional supply and demand for the supply chain. So like I was mentioning before, we've been working with a couple of port authorities to help understand, can we provide the rail activity that's going to be happening as a leading indicator to something that's going to disrupt their operations. So we've been doing a lot of work on that area as well and have some good understandings there. And, the community impacts, especially as it relates to responsible AI, and I mean, I'm not going to downplay the congestion issues and supply chain issues, but, as it relates to the responsible use of AI to provide a societal benefit, really, really happy about to talk about the community impacts, especially as it relates to emergency responders. We actually had a bit of a groundbreaking project with the U.S. Department of Transportation. It was the first time that they had ever contracted a Canadian company to do research in Canada, so outside of the U.S. First time they'd ever funded that. And so here at the city of Winnipeg, we started measuring and quantifying the risk of emergency responders being exposed to active rail crossings. So how frequently are they delayed? How much is that delay? What areas of the city are most impacted by this? And got great results from the study. It was fantastic, but we got some really interesting insights. We saw like gravitational centers in the city being driven by social demographic characteristics that were influencing responder origins and destinations. So we started training a model to train off of Winnipeg to say, hey, well, can we predict somewhere else what the origin destination paths are going to be? And so far, in a number of cases, we've been successful in training that and working with the University of South Carolina to provide some validation on this. But we're going to be scaling that research out to see if we can actually build a model of all of North America and infer the risk of responders being exposed to active rail crossings across North America without having to go to every single agency and say, hey, give me your call log data. Install all of these sensors. We'll be able to do for a fraction of the price and really understand the impacts. And so, yeah, we're really excited about that and provide that societal benefit. And I mean, that's what it's really all about. It's all about the benefits, right? So we're have a responsibility of not just doing AI for the sake of AI, but to actually provide a benefit to consumers, to our societies, to our communities. And so, for us, it's really important for us to be quantifying those things. And so some of the benefits that we're seeing, I put an asterisk on this top one here because this is really preliminary when I talk about being able to have a 5-day indicator for supply and demand changes. That is very case specific, so I wouldn't go and broadcast that we can do it across the entire network. But in the locations that we're experimenting, we have been able to see that. So we are seeing a 22% reduction in vehicles interacting with trains. And so if you recall back that stats on, $30 million a day thrown away in our economy with accidents at grade crossings, we're able to cut that in by 22%. And then also, the traffic delay piece, we're able to reduce it by as much as 30%. And that's a pretty, pairing those two numbers together, those are really important numbers when you look at the cost comparison of a solution like this versus building a bridge. And we were able to do that assessments and find that we are 125 times more cost effective than building a bridge. And I'm not going to go there and say we should never build a bridge over rail crossings ever again. But what we're finding is that, how cities and states and provinces build bridges is they look for federal funding. And they look at these benefit cost analysis to understand, what's the benefit of the investment from the feds. And, what we've been able to do is to say, fine, build a bridge here, but let's let the bridge be strategic in supporting maybe 9 adjacent rail crossings. And so your benefit cost analysis now is going to be, 9 times, what it could have been. And so we're finding we're able to pair up to these grade crossing projects and provide a lot more value for community and, reduce the overall cost to the taxpayer. And, I'm meeting on Tuesday with Transport Canada, and they're talking about rolling this out as part of their core strategy for funding grade crossing separations, just to be able to address a broader issue with less cash. And then looking at the first responder delays of rail crossings, we've quantified it. We're reducing those delays by 90%. I'd even go to Charleston, South Carolina, where they were measuring that. I'm always terrified to say this number, but they don't have any more delays at rail crossings for the responders. I'm sure it's more like a 99.99999%, but they're happy to say they don't have the issue anymore. And so again, when looking at the responsible use of AI, it really does come down to the benefits that you're providing. And so what's next for TRAINFO? There's only so much that we can do with a rollout where we are just working with one or two cities here and there. Having this data at scale will really go a long way to, as we strive to democratize all this. And so we're working with the U.S. Department of Transportation on strategies to make this data available at scale to expand the research, expand the learnings we can have on it, but also provide the initial benefits that we're providing. Our team, we're actually re-engineering our entire data architecture right now. So we're moving to a hybrid graph, SQL, and NoSQL environment. And Dave can attest to this. I'm a large advocate of graph data architectures for not just the statistical theory side of things, but the data architecture itself. I think it's just a fantastic way to approach modeling data when you are dealing with complex networks. And I'm a big advocate for that. So I'm really excited about the progress that we're making on that side. And we're going to be looking at developing partnerships and with data providers and supply chain entities to further that research into how can we be a leading indicator for change in the broader supply chain. And with all that, we're ramping up research into AI to generate new and enhanced supply chain insights. So bringing it all back to responsible AI, the three things that I would like to pull for, the two things, and the third one's just kind of a broader observation from my experience over the last 10 years. Transparency will breed understanding and acceptance. So, we all want to jump to these, more complex and sophisticated structures, but sometimes it's hard to sell those things. It's hard to demonstrate them and get people to buy into it. And so if we really want to be responsible in the acceptance of AI, we really do have to find ways of doing it in transparent ways that people can be really accepting of it. It has to be about the benefits. It has to be about what benefits are we providing here from a market perspective, societal perspective, from all these different perspectives, and not just AI for the sake of AI. I'm as guilty as anybody where I love fiddling at home and toying around with something and learning things, and often I get more excited about what the AI is doing than for the technical perspective of it than actually what the value it's bringing. I'd say 90% of things that I built in my spare time. Fantasy football forecasting, does anybody really care about that? But it's been fun to build. And then, just my broad observations, just having worked in this space and collaborating with university and industry for a number of years, there's a need for industry and academia to meet in the middle. And what I mean by that is, both sides have a responsibility here to see this get rolled out in an affecting, meaningful way. And, academia's got a very, very strong sense on the theoretical approaches and a very heavily driven research initiative and objectives that they have to meet. But the reality is sometimes industry is not where they're at, but industry is not necessarily going to recognize that because this is all new to them. These are all just new terms that we're all trying to wrestle with. And so what I mean by, meeting in the middle here is, academia needs to really understand where industry is at and not, get involved in research that's going to fall flat because we can't sustain it. We don't have the appropriate structures, data architectures in place to be able to see this meaningfully be rolled out and sustained long term. And in a lot of cases, industry partners don't know where they're at yet. So that's all I got here for now, and I'll leave it there.
Thank you very much, Neil. This was very, very interesting and quite applied, I'd have to say. So we have some questions from the audience. The first one's up on the screen. Which dimensions of responsible AI are applied in your context?
Yeah, responsible AI, it's societal benefits to make sure that we are providing value to society. It's not just AI for the sake of AI, but we're doing it for community good and for market good and all those things. And even just with the responsibility of this being a new wave, a new push of innovation that we need to foster the rollout of to make sure that we are doing this in a way that's is transparent and open that people can understand and can really adopt and get behind and trust.
Mm-hmm. So there's another question here. Where in your process is human intervention required? I guess this goes to the heart of human in the loop decision making. In light of earlier comments from Ben Schneiderman, how do you think about replacing versus augmenting human capabilities?
Well, there's a couple levels of that. So strictly from when we train our models, we won't roll it out unless it's been vetted. So we always have somebody who's in there reviewing what the model wants to do and saying, yeah, this seems reasonable, so that we don't get some kind of, some kind of unexpected, number thrown out there. But on the other side of it, the way that it's used for us, it's the only way we're actually going to be fully eliminating. Well, it's tough to answer this unless we look at a few different dimensions here. On the automotive side and the congestion and road safety side, we actually do see humans being pulled out of the equation entirely as with the advent of autonomous vehicles. So with the issues that we're looking to address with congestion and safety at rail crossings, ultimately the majority of those issues are a result of human factors, human behavior. And so I do see in that context, I do see the human equation, the human element of being pulled away. But again, that's more of a question for the ethics of autonomous cars than it is for us, and that's a whole different rabbit hole that we could jump into there with the ethics of how do you decide who is going to die in a collision? How do you make all those different decisions there? And that's a tough one to talk about with autonomous vehicles, and I wouldn't digress that for my discussion here, just because it's not an area that we have too much influence on, but just more supporting that, whatever that outcome might be. But as it relates to first responders, we integrate into the dispatch systems and influence unit recommendations. So in a large way, if you talk to any emergency responder, the toughest part of the job for them is to be able to decipher so much information at a single moment in time, to be able to dispatch the units in a very time-sensitive way to improve response times. And so we are just part of the decision-making supports of their existing human interaction. And so we don't see that being eliminated. We just see it more of a decision support tool, and they can decide that whatever unit is being recommended, we provide the transparency to say why with the dispatch software vendors as to why this is being recommended, and ultimately it's up to them to decide to use that the recommendation. And then same thing with supply chains. It's information, it's suggestion, it's recommendation to be able to distill so much information, boil it all down that a person's not going to be able to do. But to allow for us to be able to have those decision support tools with consideration of so many more variables and so many more attributes. And so I don't see that we are circumventing human intervention so much as we are supporting human response.
Mm-hmm. So when I was listening to your talk, I couldn't help but think about this example. Any AI ethics course you take, the first example that everyone's heard about is the train, and whether you go to the left and you hit one person, you go to the right, you hit more. And so in your situation, I understand you're really focused on the technology, but when working with your end users, your partners, how do you ensure that they really understand the implications of your AI-based solutions on their current processes, right? It will, in some cases, revolutionize how they use or make decisions. And how do you actually help them understand the implications of your technology?
Yeah, well, that's a great question. And I mean, so a big capability for us is systems integrations. So integrating into traffic management systems, which is a safety critical system, integrating into dispatch software, which again is another safety critical system. And I talked about with autonomous cars, we're doing a lot of exploration there, but obviously that's a very much a safety critical system. And none of these integrations come easily. So for example, it took us 3 years and government lobby, we actually were recognized by the US Congress as an innovation that should be considered for first responder issues. And it took that level of influence to get those vendors to start considering this kind of influence into their systems. And so we don't take it lightly, and they certainly don't take it lightly. We have to come to the table ready to be able to address, all kinds of issues, all kinds of security issues, all kinds of redundancy issues and things like that. And so how we approach it is really collaborative, and it's case by case, and making sure that in every scenario we provide strong fail-safes so that if we fail for whatever reason, there's protocol in place to ensure that we aren't, hindering any other systems that are depending on us.
Wonderful. I heard you talk about at the beginning of your talk about democratization of the rail data, train data.
Yeah.
So what does that actually mean? What do you mean by democratizing that data?
So what I mean by that is, if you look across North America, there are really 5 main freight carriers, and so those carriers, they're running a business, and it's in their best interest to hold on to as much data as they can and not share unless they absolutely have to. And so I completely understand a railroad's position to not share data. There's no incentive for them to do that. And so, but again, there's all these consequences of that occur that I was describing earlier. That when I say democratizing the data, for us, it's really about making it available for people to understand how the rail network truly influences them in a quantifiable way that is defensible and can enact change. And so when I talk about democratizing it, that's really what it is for me. It's about making sure that we can make the properly informed decisions with consideration of this monstrous network that sits in the middle of a lot of what we do.
Mm-hmm. I have one more question here from the audience, but I really want to follow up on that democratization. Railroad would be considered a significant infrastructure.
Oh yes.
And wouldn't democratization kind of go to create liability for when the data is becoming open and cause all sorts of issues when you aggregate all of that huge amounts of data?
Well, I think that's a if you were to talk to the railroads, that's a big reason why they don't share the data. They are very much concerned about the liability of that. And so that's something that we take into consideration as well. And so we've done all kinds of risk assessments on what happens with the data we're providing if there is liability on those pieces there. And so we do address that in terms of how anybody does with service agreements and things like that. But you're absolutely right. There is a significant consideration that has to be made in terms of the liability of this data because it is critical infrastructure. It does connect to so much. But I don't think that means that we should not be striving to have proper visibility within there.
Right. So last question for you. You talked about industry and academia meeting in the middle there. What do you think each sector needs to do, or how should they change to make cross-sector partnerships more effective?
Yeah, I mean, I think that on the academic side, I completely understand the need to publish. I think that's incredibly important. There's a significant objective to continue to push theory to be able to make advances for the benefits of society. But I don't think that we can expect our industry partners to be where we need them to be if I'm an academic. And the reality is that if we do go in there with that expectation that the industry is where we want them to be, we may provide them something or build something or research something that they can't stand up, that they can't support, that isn't going to have the legs to run. So I think it's important for the academic space to be able to really recognize where their industry partner is truly at. And I don't know how many people here are familiar with the Big Data Maturity Index. I read it from Bill Schmarzo, the former chief technology officer from Yahoo. I'm not sure if he coined it, but it's something that I've leaned into a lot. But just recognizing where industry is and those companies are as it relates to that maturity index will go a long way to helping us understand, where are you really at compared to where you want to get to, and what do we have to do from infrastructure perspective to get you there. And not pushing bleeding edge research on something that won't be able to stand once academia is out of the picture. And on the industry side, I think it's a level of just understanding the realities of standing up AI and standing up big data. It's not a magic wave of the wand unless you're looking at somebody to provide you the service. If you're looking at building it in-house and having it be your own IP, it's a much larger endeavor than just exploring the data.
Excellent answer. Thank you very much, Neil. I think everyone enjoyed this presentation, very practical and interesting. So thank you very much for joining us.
No, thanks for having me.
Thank you.